You're given an infinite series. What do you need to think about first? Why does this say think about the limit? Divergence test. If the limit equals anything but 0, can we say right away we're done? Diverge. Right? Now maybe like in a few weeks when you have a test and you're supposed to show me all 10 tests, maybe you see multiple ones that diverge and you're like, I'll just use the divergence test on this one and I'll use something else on that one. But anyway, the limit right away can tell you if it's what again? Not 0. Not 0. Diverge. Done. All right, well that was hard. If it is 0, nothing. We know nothing. And so then we go attacking the other 9 tests. But for our purposes, we don't know them all, so we go attacking more tests. What are the tests that we know so far? Geoseries. Okay, how do we recognize a geoseries? Someone tell me something.
Something to the K. R.
Find R, if there's an R, right? There has to be, well, that one's not a very good geoseries. Not all of those are geos. I can't go backwards because of my screen. That's all right. If you see things to the N, it could be geoseries, like in the actual... Man, what's that called? The formula for the sequence. In the nth term formula, is that cool? In the nth term formula, if you see something to the n, if you see like 1 over k to the n, or if you see 3 to the n over 2 to the n plus 1, I don't know. Something to the n, it's possible to be geo. If it's not something to the n, it's very unlikely to be a geo. But wait a minute, what are we supposed to be doing every time we see a series anyway? First things first. Maybe take a limit, but write out a few terms, right? And that way we can recognize the ratio also. If it is a geoseries, if there is a common ratio, what does the ratio need to be for it to converge? Between -1 to 1. Including? No, not including 1. Because if you just keep on multiplying by 1, aren't you adding the same number over and over again? And 3 plus 3 plus 3 is not going to converge. 3 minus 3 plus 3 minus 3 plus 3 oscillates, also not going to converge. Okay, good. So if the ratio is anything except for in between 1 and -1, diverge, geoseries. If the ratio is in between -1 to 1, converge. And what does it converge to? Special formula? An a sub 1 meaning the... No, that's good. The first term. Yeah, the initial term, all over 1 minus r. Okay, that was section 9.2. Section 9.1 was like sequences, take limit. But 9.3, more tests. The only one we've seen so far is the integral test. What 3 things have to be true for the integral test? Continuous, positive, increasing, to forever. We could deal with a little bit of struggle here as long as to forever, continuous, positive, and decreasing. Do you need to be showing me tons of work even though there's a lot of calculus behind showing definitively what it is? No. You just need to be able to see that it's true. And I told you, watch out for logarithms in general. When is the integral test good? When you can integrate. If you can't integrate, should you use the integral test? Just thinking ahead. No. But does that mean every single integral is going to be easy? No. But coming back, the integral test, what do we know? If we're allowed to apply it, the improper integral from the lower bound, whatever he is, starting at 0, starting at 1, starting at 2, the improper integral, if it converges, the integral converges, then the series converges. If the integral diverges, then the series diverges. It's a great test because it shows us convergence and divergence. But what test didn't we get to on Friday? P-series. Time for a new test. And also time for me to get rid of this yuckiness. Hold on. Oh, hi, frozen computer. Go team. Okay. I didn't like the way the original one was written. So I just crossed it off, but that's really messy. I apologize for that. Let me just white it up. If P is a real constant, the series from 1 to infinity of 1 over n to the p oh, that didn't work. Bring to front.
So all of these are in Endeavor card?
Yep. We made the one on Friday in Endeavor card, right? The integral test?
Yeah.
Oh, no, thanks. So what does that make this one as far as number? 16. I'll zoom in. I was getting it all nice and pretty. This one attaches This one attaches to I think it's endeavor card number 12. What order did we do? Did we do P greater than 1 first? I don't remember the order. This one ties very closely to the special improper integral. From endeavor card, I think it was number 12. It ties very closely together. If P is a real constant in the series from 1 to infinity, which equals, okay, plug in 1, plug in 2, plug in 3, plug in 4, will converge if P is greater than 1 and diverge if P is in between 0 and 1. Oh, I did it backwards up there. Silly me. Lo siento. There we go. That wasn't very helpful, was it? And if you ever forget the P-series test, you could always pretend it's an improper integral, and you could integrate, and you would realize, and we talked about this briefly on Friday, Thursday, whenever we were talking about how 1 over x diverges and 1 over x squared does not, or 1 over k diverges and 1 over k squared does not. If you were to integrate, for instance, let me put it in red, it's an example. Improper integral from 1 to infinity of 1 over x. Who is he? ln. And ln of b minus ln of 1. Yeah, I can do absolute value. What happens as b goes to infinity? Diverges if you have 1 over x. What's going to happen if I have 1 over square root of x? X to the negative 1/2. The integral is going to be x to the positive 1/2. That's going to go to infinity as well. What if I have 1 over x to the 4/5? Integral is going to be x to the 1/5 with a constant. I realize that. But going to infinity is going to be infinity as well. If I have a power that is 1 or lower, can help you remember the P-series test if you ever forget. But what happens if I take the integral, the improper integral? And we could even be so snazzy and be like anything greater than 1. How about 1 over x to the 5/4? Or x squared, or x cubed, or x to the 4th. But this is just a little bit above 1, right? What happens when you integrate them, though? X to the negative 5/4 plus 4/4 is x to the negative 1/4 times negative 4. But still, what's true about this guy? It's going to be over, right? And when you take the limit as b goes to infinity and you plug in, isn't that going to end up constant? Because what? Negative 4 over b to the 1/4 is going to go to 0 minus negative 4 over 1 to the 1/4. Yeah. If the limit is a constant, the improper integral converges. The improper integral converges. The series converges. So you could actually, with any P-series, you could do the integral test. It's just faster if you don't have to. What's going on if P equals 0? Why didn't I write that one? All I have is P. Anything to the 0 power is 1. Yeah, exactly. If P was equal to 0, then we'd have the infinite sum of n equals 1 to infinity of 1 over n to the 0, which is just the infinite sum from n equals 1 to infinity. What's 1 plus 1 plus 1 plus 1 plus 1? According to the divergence test, the limit is 1, which is not 0. It diverges. Or just logically speaking, it diverges. Huh?
If it still diverges, why not just make it greater than or equal to 0?
Well, the idea is if p is equal to 0, it's not truly a p-series. Does that make sense? So I would say a different test should have been used, not the p-series test. And then what if p is less than 0? Why is this also not a p-series technically? Yeah, because if you had n to any sort of negative 2, for instance, isn't that really just? So I'm just going to put a dot, dot, dot. Technically, these both would diverge. But I'm going to put a dot, 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 because basically the p-series test does not apply. P-series is specifically 1 over n to a positive power. So this is just a quick little like, hey, but what about, and why aren't they included? Well, they're not truly p-series. So we need powers greater than 1 for a p-series to converge. Let's play. Ready? What can we say about the beginning? Oh, I don't want that. Can you guys read it? Is it too small? Maybe for a couple. 2 over n. Divergence test. Limit as n goes to infinity of 2 over n. What do we got? But divergence test, sorry. The limit as n goes to infinity of 2 over n. Because eventually that's the first thing you're always going to look for. What's the limit? So we know nothing, right? Okay, good. Just checking. Could we do integral test? Yeah, sure, I guess. We could do. We could just leave it there. I'm trying to think if I want to keep going with that. Yeah. Mm-hmm. Not within. I could do it that way. Since p is equal to 1, which is not between. Why do I keep switching this in my head? Did you guys figure out I just switched it? 0 to 1 is the divergent, right? Which is not. Yeah. There you go. There you go. That's easier.
Could you say like not between 1 and infinity?
Yeah, you could. I don't know. That was just messy in my head. P needs to be greater than 1 in order for the series to converge by the p-series test. And the nice thing is, does this 2 cause us a problem? No, because properties of summations. Remember, this is an infinite sum. I can factor the 2 out of everybody. So ultimately, I'm looking at 1 over n. How about number 2? Yeah. How come? Yeah. We could even just do that greater than 1. We can just stick with that, I think. Either it's not greater than 1 or it is greater than 1. Since p is equal to 2, greater than 1, series converges. How about number 3? It's not p-series, so what do you do? Yeah, I would do the divergence test, right? Because 3n, what's the limit of? Infinity is not 0, right? What can I say? Diverges by, what do you guys want to call it? Divergence test, nth term test? Divergence test.
My question is, are they going to ask us to what it converges to?
So far, the only thing that we can answer as far as converging to a value is geoseries. Everything else, we're only able to answer right now, converge or diverge. Mm-hmm. It's actually impossible to say without approximation techniques what these series are converging to, except for one. There's one exception to that. There's geoseries and telescoping. We can say what those are converging to.
So on the exam, they probably wouldn't ask us. They're just going to ask us if it's diverging or not.
On an exam, if they're saying something about converging to, they're talking about probably Lagrange error bounds, and approximations, not exacts. Or a geoseries. Are you?
I'm sorry, did you say we could use the, I think it's sigma, like in FRQ, or do we have to write out series?
I haven't actually seen a convergence divergence one on an FRQ, have I? Oh, no, I might have seen one. I would write out the word series. I think they probably would take it because they know what you mean, but I would still write series. How about number 4? Got it. Because what's P? Not greater than 1.
This one's good. This one's like super easy.
Mm-hmm. But it's super easy until you learn 6 more, and then you forget what the characteristic is that you're supposed to remember. Because there are other ones where greater than 1 means and less than 1 means, and it might not be the same. Just a warning, because right now it's going to be great and it's going to be easy, but you need to actually, I was going to say internalize.
We should make
Like a jingle to go along with parting C?
to go like these series. Yeah, that's good. That's so catchy.
To start. Okay.
I give nothing on me with my music.
How about number 5? Yeah. Because this is technically the same thing as?
I have a 0.5.
And then? What's P equal to in this one? I was going to say it's negative, we can't do it, but it's positive as long as you rewrite it as? Right? People that were typing before there was the ability of subscripting. That's my guess. But I don't know. A lot of things that you think, well, not a lot of things. But there are quite a few things that I think were just for people trying to type out math before all this nifty equation editors and whatnot were a thing. P-series test, not bad, right? As long as you remember, if P is greater than 1, I know, right? P is greater than 1, converges. If P is less than 1, or not greater than 1, I should say, diverges, right? Ready, set, go.
When the assignment was due.
Pause, time out. I'll answer that in a bit. Go.
He's like, how do I correct my one?
So since the top is to +1, you can separate it.
I'm going to start playing people just joining us. The one thing the kids got tricked on was that this said sequence. This is from section 9.1. Our section 9.1. This one converges specifically to 5/2. The sequence, not series. This one diverges because the limit would be infinity. The top wins. Degree test. This one converges. The sequence converges because degree test, there's a tie between my e to the n's. Number 2 is just pointing back to the integral test. In the integral test, if we have a positive continuous decreasing function and the conclusion was that the infinite series converges, the improper integral must have converged as well. Number 3 is what a lot of people are thinking through right now.
That's what I was kind of trying to figure out what it was like. So it doesn't it say converges?
It says the infinite series converges, and so if the integral test could have been used, which it could, and the series converges, that means the improper integral must have converged to begin with. It's kind of like the backwards of the test. This one, why am I pulling out a 2? Did you guys figure out this was a geoseries with the common ratio being 2/3? And 2/3 is? Less than 1, which means the series converges to a sub 1. What was a sub 1? All over 1 minus 2/3, which would end up equaling 4, technically by the geoseries test. Nah, technically they were just asking what the value is, but I was just showing why it converged and reminding you guys that the test does lead you to the infinite sum if it exists.
So we could have just put 4.
By the p-series test. Yep, since p equals 0.99, which is not greater than 1, series diverges. How are we doing? I think we should go check out a calendar, because remember how I said there was going to be a quiz somewhere or others to make sure that you guys have solid, what you need to have solid before we move on? Guess what's tomorrow?
No. Oh my gosh, already?
Not a forever quiz. But if you don't know the tests, how well are you going to do? Now, we are going to go over homework questions in section 9.3. As you guys realized, 9.3 isn't meant to be hard. Doesn't mean it won't get tricky at all. Isn't meant to be hard. It's better to have a quiz now before we get into the harder tests, because we already have 4, which is almost half. There are 10, technically kind of 9. This is a good stopping point. However, man, that wasn't a very long review. Hey, there's more. I'm going to go ahead and post in your guys' Google Classroom tonight the review for you to keep on playing with, together with an answer key. Oh, there's the answers. Anyway, let me post that in your Google Classroom. You guys can keep reviewing, but work on your 9.3 homework. And for tomorrow, 9.1 is just limit of sequences, converge, diverge, based on whether it's infinite or oscillating or not. But then 9.2 and 9.3, you have 4 tests. Divergence, nth term, geo, integral, p-series. Get out of here, cool kids. I'll see you later.
Wait, is it Misty correction?
Oh, corrections. Since we have the quiz tomorrow, I'll probably do the end of the week. Yeah.